So here we go. All right, number one. How many ways can 7 books be arranged on a shelf? What do you think? 7 books on a shelf.
This is 7 factorial.
It is 7 factorial. That's exactly right. So the answer is 5,040. I think that's what 7 factorial is. So make sure you know how to type that in on your calculator. Get 5,040 as the answer. Perfect. Tuan, I need your video on, please, so I can see your face. Leo, same with you.
I'm doing my notes, notability. I sent you and the thing in the chat before class.
Okay. Leo.
I'm trying to print off the paper real quick.
Okay, yeah. Leo, I gave you hard copy notes or hard copy practice
No, I still
tests.
have my backpack on me.
Okay. Well,
My sister took the car and I have my backpack.
Okay. All right. Well, I need you to make sure you have what you need going forward, okay?
Okay, sorry about that.
How many outfits are possible if you have 4 pairs of pants and 6 shirts? This is number 2. How many outfits are possible? 4 pair of pants and 6 shirts. What'd you say? 24. Somebody said 24, and that is exactly right. Because you got to go to your closet and you got to pick a pair of pants, and you have 4 choices, and you have to pick a shirt. You have 6 choices. We've done a lot of these kind of problems where you have choices. And when you have choices, you multiply them all together. So 24. How many ways can you answer 8 true-false questions? What do you think? What'd you say? No, but I understand what you're saying. If you have 8 true-false questions, think of the answer sheet for that quiz. It would just look like this. How many choices do you have for this blank? 2? How many choices for this one? Don't you have 2 choices for each of those blanks? So it would be actually 2 to the 8th power. 2 times 2 times 2 times 2 times 2. It's just like the shirt and pants problem, except there's more. Yep, so that would be 2 to the 8th, which is what? 256? 256. Now, I'm going to give a pencil, a marker, and an eraser to a class of 12. So I've got a class of 12 kids here in my bundle, a class of 12 kids, and I'm going to choose 3 of them to give a pencil, a marker, and eraser. What do you think?
12 times 11 times 10.
One way to do it is 12 times 11 times 10. Perfect. Another way to do it is 12p3. Those are exactly the same thing. If you evaluated those, you would get exactly the same thing. Why is this a P problem? Because they are getting different prizes. When you are picking for different prizes or different roles, different jobs, different anything, you're going to need a P. Okay, Courtney, I don't think she can hear me. If anybody has Courtney's phone number, would you tell her that she needs to disconnect and come back? Because right now I'm not counting her present. So can somebody get a hold of her and tell her that, please?
It was $40.
All right. All right, next. Oh, what was the answer to that, by the way? 1320, okay. And it can be done either way. Both of those are perfectly okay. You're picking a marker person, an eraser person, and a pencil person. Perfect. That will work. And so will 12P3. All right, next. How many 8-letter words can be formed from the letters of prettier? All right, so you started with 8 factorial, Hector, and that's exactly right. So it's 8 factorial because there are 8 letters, right? 1, 2, 3, 4, 5, 6, 7, 8 letters. But we've got a couple of R's, so we'll divide by 2 factorial. That takes care of the R's. We got a couple of T's, so that's another 2 factorial for the T's. We have a couple of E's, so that's another 2 factorial for the E's. Is that it? Yeah. And when I type that in, I do it very carefully because I need to divide by that whole shebang. So I think that's 50-40. Again, I think we get 50-40 when we do that division. Number 6, how many ways can 10 people be seated around a campfire?
Not just 10 factorial.
Okay, I don't know that we talked about this in our notes. So actually it's not 10 factorial. Listen carefully. If we were seating 10 people in a row, like on a log, it would be 10 factorial. But since we're seating them in a circle, it's 1 less. So it's 9 factorial. So when you arrange things in a circle, so around a campfire, around a table, around a flagpole, when you arrange things in a circle, it is 1 less factorial. So when you have 10 things in a row, it's 10 factorial. But when you have 10 things in a circle, it's 9 factorial. So we need to make a note of that so that we remember that because it's the first time we've talked about it. In a circle is 1 less factorial. So you guys got it. When you're in a row, 10 people is 10 factorial. Right. But in a circle, it would be 9 factorial. All right, now number 7 actually is like a card problem. Only instead of clubs and spades, we have boys and girls. So we have 3 boys. Oh, no, we have 10 boys and 8 girls. And we are going to pick 3 boys and 5 girls. So I heard Hector back there say 10C3. That's how I picked the boys. I got 10 boys, I'm choosing 3, perfect. And 8C5, bingo, that's it. You're taking 3 boys out of the boy pile and 5 girls out of the girl pile. So that answer would be 10. Now I'm going to quit typing all these in so that we can get through more material. Hopefully you're practicing with me right now to make sure you know what you're doing. I got 6720. Is that what you got, Hector?
Yep.
Perfect. All right, what was that, 7? So now we're ready for 8. What is the probability of being dealt a 5-card hand that is composed of all diamonds. So we want 5 cards, all diamonds, and it's a probability question. When it's a probability question, guys, you have to make a fraction. So probability is going to be a fraction. Always. On the bottom goes the total, which is 52C5. That's the bottom of every card problem where you're picking 5 cards. 52C5, that's your bottom. Now your top is all diamonds. Okay, all diamonds. What will that look like? Anyone know? Out there in virtual land?
52C13.
That's a great guess, but I want you to stop and think about what that means. This means you have 52 cards and you're picking 13 of them. Is that what a 13C5? That's what we want. Because, Gabe, there are 13 diamonds and I need to pick 5 of them. The first number is how many you have to choose from. There are 13 to choose from, and I am picking 5 of them. Remember, the numerator is what you want. I want diamonds. So there are 13 diamonds to choose from. All right, I'll let you type that in on your own. What is the probability of being dealt a 5-card hand that has 3 aces? Exactly 3 aces. Won't the denominator be the same thing? It's a 5-card hand. But now I want 3 aces. Exactly 3 aces. What does that look like? Exactly 3 aces. How many aces are there? 4. And I'm picking 3 of them? Oh, there she is. Courtney, I need to see your face, sweet pea. All right, so 4C3, but I'm not done. Can anybody tell me what else I need? What else do I need in this problem?
4C2.
Okay, it's something C2, but it's not 4. What do the other cards have to be?
48.
It's 48. Because the other cards have to be something besides aces. So if there are 4 aces and I'm picking 3, then there are 48 other cards that aren't aces, and I'm going to pick 2 of them. So those 2 get multiplied together, and then we divide by that. Guys, this part is always tricky because it's not mentioned in the problem. All that's mentioned in the problem is the 3 aces. But you have to remember that if it's 5 cards all together, you still need to pick the other 2. All right, now number 10 looks a little bit different. Can anybody think of a strategy we might need? Read number 10, and what do you think that strategy might be? I don't think I'll use C's, like I've been using C's here with my card problems. Exactly. This is going to be a conditional probability. This is going to be, rain and no rain. So when I set up my tree diagram, remember the bottom level, the very bottom of the problem is the question. So the bottom of the problem is tennis. So this is going to be tennis and no tennis. Tennis and no tennis. And then what will the first level be? Rain. Rain and no rain. Okay, guys, you got to make sure that you get the words put in there correctly in order to get, your numbers put in correctly. Okay, we're good with that? Everybody okay with that setup? All right. Nathan, please just get your face on the screen. Courtney, you too. All right, so let's put in some numbers now. If it rains tomorrow, the probability that I will play tennis is 15%. So if it rains, 15% probability of playing tennis. If it doesn't rain, the probability is 90. The probability of rain is 45. Now take a moment, everybody, and make sure that you get why I put those numbers where I put them. Everybody got that? Now, what do I know about these two right here? What do these always have to add up to? They always have to add up to 1. So if that's 45, this is 55. If that's 15, this is 85. And if that's 90, that's 10. Now you are going to have a calculator, so if you can't do that in your head, that's fine. Type it in on your calculator. But these always have to add up to 1. Each of the little V things adds up to 1. All right, so now we're going to answer the question. Find the probability that I will play tennis. So there's a tennis and here's a tennis. So I need to find the probability of those branches. So you got to start at the top and get down here. Follow the road straight down. And we multiply 0.45 times 0.15. So 0.0675 is that one. And then likewise here, we got to follow the road all the way down. So 0.55 times 0.9. And then, what do I do with those two different answers? I add them. Absolutely, I add them. So when I add those together, I got 56.25%, or 0.5625. Remember, you can answer as a percent or as a decimal, whatever you like best. All right, number 11. 50 seniors in the chapel. All of them are singing and or praying. 25 enjoy singing. 32 enjoy praying. How many only pray? What do you think about a setup for this one? I don't think this is going to be a tree diagram. What is this one going to be? Do you think?
Is it the same with the cars?
This one's going to be a Venn diagram. Yep. Because you've got two groups of people singing and praying. And some of them are doing both, apparently. All right, so we got 50 kids in there, total. All of them are either singing, praying, or both. So there's nobody out here. They're all participating. 25 enjoy singing, and 32 enjoy praying. Now we got a bit of a problem here, because we only have 50 kids in the room, right? And what do these add up to? 57. So I got 57 hands raised, but I only have 50 kids in the room. So doesn't that mean 7 kids raise their hand twice? Don't I have 7 extras? So those 7 people got counted twice. Now, remember, the whole S ball is 25. So if 7 of them are already here, then that must mean there's 18 here. And if the whole P ball is 32, there must be 25 here, because 7 are there. So now I can answer the question. How many enjoy only praying? Only praying would be 25. Is that good? 25? All right. Number 12, expand x minus 2y to the fourth. All right, so expand means we have to get it all multiplied out. So you can either use Pascal's triangle, and that's perfectly okay, or you can remember that the numbers in the expansion are the combination numbers for 4. So 4C4, 4C3, 4C2, 4C1, 4C0. Those are the numbers in the 4th row. The numbers in the 5th row would be 5C5, 5C4, and so on, all the way down to 5C0. So this will work, so will Pascal's triangle. If you want to build Pascal's triangle, that will work too. Oops, getting ahead of myself. You can go ahead and build Pascal's triangle. Okay, so type, if you use the triangle, then you know what the numbers are. Otherwise, you have to type these in on your calculator, which is fine. You all have a calculator. So the numbers are 1, 4, 6, 4, 1. Those are the numbers. They come straight from the combinations or from the triangle. Do you remember that next to each of these numbers you put an x and a negative 2y? In parentheses? Does everybody remember that? And then we start putting powers into the problem, exponents into the problem. So remember that the first x, in the first term, the x will be to the 4th, and then they count down. And then the y's do the same thing in the other direction. And you are all done except for the simplifying. Does anybody have a question about that setup?
How did you go from 4C3 to put that equation?
Okay, the two people were talking one at a time.
Trey, you can go.
How did you go from 4C3 to put that equation under?
These numbers, 4C4 is 1, 4C3 is 4, 4C2 is 6. I type them in on my calculator. I happen to have those memorized, but you just type them in on your calculator.
You subtract them? Or add them? I'm lost.
No, I write down these numbers. So I wrote down a 1, a 4, a 6, a 4, and a 1. I don't do anything with those numbers together. I mean, those numbers don't do anything together. I don't put them together at all.
You get the number much more.
What? What?
Or Sam, how did you get those numbers?
On my calculator.
How did you get those numbers?
On my calculator. If you type 4C2, it will say 6.
Okay.
And 4C1 is 4.
Alright.
Okay? They come straight from the calculator. Alright, now we simplify each term. And when we simplify each term, we remember that anything to the 0 power, anything to the 0 power is going to just be 1. So I can pretty much ignore that. And so I just have x to the 4th there in the beginning. Now here, I'm going to have a 4x cubed times a negative 2y. This is a multiplication. All this is being multiplied. So that's going to be negative 8x cubed y, because 4 times negative 2 is negative 8. Now this one's 6x squared times positive 4y squared, because when I multiply a negative 2y times a negative 2y, I get 4y squared. So that term is 24 x squared y squared. And this one is 4x times negative 8y cubed. Remember, we got to cube the negative 2. So negative 2 times negative 2 times negative 2. So that one's negative 32 xy cubed. And then on the end, anything to the 0 is 1. So that's just going to be 16 y to the 4th. Negative to the 4th is going to be positive, and 2 to the 4th is 16. So all of that is your answer. All right, anybody have a question about any of these terms? Anybody not understanding where one of those terms came from? Well, now we have I shouldn't say easier, a shorter version of that problem. So obviously if I'm expanding the whole thing, I get a whole bunch of terms. This time, I don't want all the terms, I want just one of them. It would be like asking for just this term, just find one of them. I know that in this expansion to the 7th power, I know that my coefficients, the numbers that I'm starting with, will be 7c7, 7c6, 7c5, 7c4, and so on, all the way down to 7c0. Yeah, I'll put it on the stool. Thank you. Oh, I forgot to email her and write a pass. Now, which one of those numbers do I want? I don't want all of them this time because I only want the 3rd term. So which one do I need?
C5.
Yep, you just count, kids. You just count. Thank you, Solar. You just count. So this is the 3rd number in the list. There's the 1st, 2nd, 3rd number. That's the one I want. So I want 7c5, which I don't have that one memorized. So let's see what that is. 21. So the number I want, 7c5, is 21. I just type that in on my calculator because that is the 3rd term in the list. It's going to have a 2x and a y. Those are the 2 parts of the problem. And now I need to put on the exponents. If I were writing out the whole thing, the power on the x here would be 7. And then it goes down to 6, and then it goes down to 5. So the power on the x is going to be 5, which means the power on the y is 2, because these always add up to the total power in the problem. So I just did there exactly what I did down here, but down here I had to do it a whole bunch of times. Here I only have to do it once. So that's 21 times 32 x to the 5th, 2 to the 5th, 32, y squared. So that simplified answer would be 672 x to the 5th y squared. All right, anybody have a question about that?
Why do you think I like it better? I'm a parent, yeah.
All right, then the next thing we've got is a little problem to do by hand. So to do it by hand, we have to remember our formula, 8c5 the formula for HC5 will be, everybody remember? It's 8 factorial on top. Yep, that number right there on top. On the bottom, subtract them, and then put the other number. So 8 minus 5 is 3, and then I have the 5. And then I just got to remember what 8 factorial is. 8 factorial means 8, 7, 6, 5, 4, 3, 2, 1. I have 3, 2, 1, and 5, 4, 3, 2, 1. And then you just start canceling however it occurs to you to cancel, whatever you want to do. Personally, I think it's easier to start to cancel all that stuff out. Now I have 3 times 2 times 1, which is 6. So the answer is 56. You can cancel in whatever order you want. As long as you're ending up with 56, it doesn't matter. You can cancel different things out if you choose. But when you get it all canceled, you should end up with just 56 as your answer. Anybody have a question about that?
Can you do that one more time? Like, just the ending part? I was not up.
Just, once you get all the factorials written out, just start canceling numbers on the top with numbers on the bottom.
Alright.
Alright, what am I given here? Those are the questions. Now here's the given. Remember, when we do these, you do not ever, no matter what the Venn diagram is, you don't put, when this says the probability of A, that means the whole A ball. You cannot put that number in your diagram. You can't put it in because 0.7 is the whole thing and it's split up into 2 pieces. The only one of these that you can put in your diagram is this one because this says A and B. A and B is only that section right there, the football in the middle. That is the A and B. Now, once you get that number put in there, now you can use this to figure out what this is. Because if the whole A ball adds up to 0.7, then doesn't this part have to be 0.4? And if the whole B ball adds up to 0.5, then doesn't this have to be 0.2? And then you can say, okay, altogether, my sections add up to 0.9. What does that tell me? The fact that these add up to 0.9. There's 0.1 out here. Because in a probability problem, and that's what these P's mean, P's mean probability. In a probability problem, it all has to add up to 1, 100%. Now, if it helps you to think about apples and bananas, that's fine, doesn't matter. This means you like apples and you don't like bananas. So this means you are in the A circle, but you are not in the B circle. Remember, that means not. So I'm in the A, but I'm not in the B. What's in the A but not in the B? Isn't it this section right here, guys? Isn't that the section? It's in A but not in B. What's this say? The second part of that problem. What does that say? You're not in either one. So if you're not in either one, you are a 0.1. You're the leftover people out here. All right, we have one more, and we'll move on to the next practice. All right, so now we've got class 1 and class 2, and their favorite subject, and we want to know, I'm going to pick a student from each class. So I'm going to pick a kid out of each box. What is the probability they both liked math? Well, what's the probability the first kid likes math? 0.6? Right out of the chart, guys? And then the second one is 0.4. Now, I want the first kid and the second kid to like math. So what am I going to do with those numbers? Multiply them. So the answer is 0.24. When you are doing kid 1 and kid 2, you multiply. Now, what is the probability of the first kid liking math? Okay, that's 0.6. And the second liking science? 0.12. Yep, multiply them together. What is the probability that neither will like art? So nobody, what's the probability that neither will like art? What do you think?
Put 0.9 times 0.9.
Exactly. Very good, Hector. 0.9 times 0.9. Because the art kids in class 1 are 0.1. So that means there's 0.9 that aren't art. And it's not likewise in class 2. So that would be the answer right there. Now, D is the harder one because it says one likes science and the other likes English. And what makes that harder is it can go science, English, or it can go English, science. Does everybody see that? It doesn't say which kid comes first. It just says we ultimately have to end up with a science and an English. So if we do science first, it would be 0.1 and times 0.3, so that's 0.03. Science and English, so science out of class 1 and English out of class 2. Or it can be English out of class 1 and science out of class 2, which would be 0.04. Now what do I do with those two numbers? Since it can be this way or this way, we add them. So the answer to the problem is 0.07. Okay. Let's move on to number 2, unless somebody's got a question about that. This test is really short, obviously. Here we go. Number 1, practice test 2. We're on number 2 now. How many different sandwiches are possible if we have 3 kinds of bread, 2 kinds of meat, and 4 kinds of cheese? A sandwich must have bread, meat, and cheese. This problem is exactly like the outfit problem. Instead of picking a shirt and pants, though, you're picking bread and meat and cheese. So when you sit down to make a sandwich, you have to pick a bread, and you have 3 choices. You have to pick a meat, and you have 2 choices, and you have to pick a cheese, and you have 4 choices. So how many different sandwiches would be possible? 24. Do you see that this is just exactly like I have 4 shirts and 5 jumpers? I have 4 breads and 5 cheeses. It's exactly the same situation. All right. How many ways can 10 chairs be arranged in a row?
10 times 4.
Yep, 10 factorial. 10 things in a row, kids, is 10 factorial. How many ways can I arrange 10 people in a row, 10 chairs in a row, 10 books in a row, 10 dogs in a row? It doesn't make any difference. Whatever I'm arranging in a row is going to be that many factorial. All right, last time it was true and false questions. Now it's multiple choice. I'm going to answer 5 multiple choice questions. And each question has 4 options, A, B, C, or D. So how many choices do I have here?
5. Wait,
4.
4. 5.
And 4 and 4 and 4 and 4. You are exactly right, Hector. That's 4 to the 5th. Because you can answer question 1 4 ways and question 2 4 ways and 3 and 4 and 5. Very, very good. All right, in number 4, I'm giving away 4 identical markers in a class of 12.
Is it 12C4?
It's 12C4. Yep, it's 12C4. Okay, 12 kids choose 4. Why is it a C and not a P? What makes the difference?
They're all doing the same thing.
Exactly. The markers are all identical. If you are giving away different prizes, then it would be a P. If you were giving away different responsibilities, president, vice president, treasurer, then it would be a P. But if everything is the same, it's a C. 12C4. All right, now we have toothpaste. And we want to know how many ways we can arrange those letters. How many are there? Always start with that. How many letters are there? 10? So we're going to start with 10. Now, what do we have repeats of? There's 2 O's right there, so that's 2 factorial. That's for the O's. Ooh, I got 3 T's. So that's 3 factorial for the T's. E-S-A-P-H. That's it. So let's make sure everybody can type that in on your calculator. We'll get that answer. You have got to remember the parentheses down here when you divide. I got 302,400. Anybody match that? Anybody else type it in with me? Good. All right, that was 5. 6. How many ways can 5 people be seated around the dining room table? How many ways can 5 people be seated around the dining room table?
Is it 4 factorial?
It is 4 factorial. Very good. The key there is we're seating them around. And when you're seating in a circle, it's 1 less. So 5 people become 4 factorial. Very, very good. All right, now I'm making a team. I have 8 seniors and 6 juniors, and I'm making a team of 2 seniors and 3 juniors. All right, so I got to pick some seniors. What's that going to look like? AC2. And 6C3. And since I am picking juniors and seniors, it will be a multiplication. This is exactly like a card problem, you guys. Start looking for similarities in the problems. This is like picking 2 diamonds and 3 spades, only it's seniors and juniors. speaking of cards, 8 is a probability problem. It will have a denominator. Be careful. It's a 4-card hand. I got sneaky. See that? It's a 4-card hand. So what will my denominator be? 52C4.
52C4.
Perfect. You're exactly right. 52C4. Now I want all red. Right? I mean, problem 8. All red. So now I'm only considering the red cards. How many red cards are in the deck?
26.
Yep. And I'm picking 4 of them. There is your setup. You'll type that in on your calculator and get some decimal or something, but that is the setup. The numerator is what you want. I want a red card. 26 of them, pick 4. Denominator is total, 52. Pick 4. Now 9 is still a 4-card hand, so its denominator is going to be the same thing. But this time I want exactly 2 queens. This is one of the tricky ones. It's going to start out, as Hector says, with 4C2. Would everybody agree with that? But we can't stop there, can we? Because we need 4 cards. Now tell me about this. If exactly 2 of them are queens, and I need 4, what are the other 2 cards going to be? They don't have to be the same.
Anything.
Anything except what? Queens. They can't be queens. Because I need exactly 2 queens and I already picked them. Now my queens are done. So the other 2 cards I'm going to pick are not queens. How many not queens are there in a deck of cards?
48.
48. Hector, you can't say 50 because 2 of those are queens and I can't pick those. So there's 48 cards that aren't queens and I'm going to pick 2 of those. And I want queens and 2 other cards. So the numerator gets multiplied together and then you're going to divide by 52C4. In this problem, think of your deck as queens, not queens. So it's 4 and 48. All right, number 10, look at it. What's a strategy you're going to use with problem number 10? We got popcorn. If we have popcorn, then we have soda. If we don't have popcorn, then we have another chance of soda. What are you going to do with this problem?
Draw the V's.
Yep. Going to make it what we call a tree diagram or draw the V's. And since the question is, read it carefully, find the probability that they will serve soda. So soda goes on the bottom. The question is, find the probability that they will serve soda. Soda goes on the bottom, which means popcorn must be here. So if we have popcorn, this is a 90. If we don't have popcorn, this is a 45. And what do I do with this? They serve popcorn twice each week.
0.2.
Actually, twice a week would be 0.4. Because isn't twice a week 2/5? Twice a week would be 2 days out of 5. And 2/5 is 0.4. So if I serve popcorn 2 days out of 5, I'm not serving it 3 days out of 5. And then I want the probability of soda. So I'm going to multiply these two right there. And I'm going to multiply these two. I did that without the calculator. That might be wrong. Okay. And then I add them together. I know some of you are, maybe all of you are bored out of your minds, guys. We're getting ready for a test. Try to pay attention. Everybody come up with 0.63 as the final answer? Got it. One more on this page. 60 students on the bus. Some of them like teaching, some of them like nursing. Everybody likes one or the other or both. All right, what's your strategy for this one? Read that question, tell me how you're going to set it up.
Diagram.
What'd you say, Hector?
Diagram.
You're going to do a Venn diagram, yep. Can't you just feel the Venn diagram when you read that problem? You've got teachers, you've got nurses. How many people are on the bus? 60. And we know that 40 of them like teaching. And we know that 35 of them like nursing. Now, you guys, the 40 and the 35 do not go into the picture, because the 40 and the 35 are the totals, and you can't put the totals in. But wait, Mrs. Ford, that's all the information they gave me.
I'll just send it 5.
Oh, Hector says these add up to 75, and there's only 60 people.
That's 15.
So 15 of them like both. 15 people voted twice. Now you can fill in the rest. If the whole T-ball is 40, this will have to be 25. And if the whole N-ball is 35, this will have to be 20. Do those numbers make sense to everyone? And then we can answer the question. How many indicated an interest in only nursing? Only nursing are these guys right here, aren't they? They're in the N ball, but they're not in the T ball. These are the only nurses. So the answer to that question would be 20. All right? I think that is a good stopping point. So let me remind, and then we'll finish all this up tomorrow, or next time I see you. Okay, guys? Courtney, would you stay on, please? Antoine, would you stay on? Lainey, would you stay on? Thank you. I'll see you guys next time.
Thank you.
Thank you.
Bye-bye. Okay, guys, I am not, see, Twan, how you are right now, that's how you need to be during class, all right, with your face showing, all right? Lainey, I cannot see anything but a couple pieces of hair on the top of your head. Courtney, I haven't seen you all, period. So Courtney, and all the rest of you, I'm not doing this. It's stupid. You know what you need to do it. I'll just keep marking the absent. And that's not good for anybody, okay?
I moved my camera for like the last 3 minutes.
Twan, I need your camera on your face the whole time. No excuses. No excuses. And Courtney, I don't know what you got going on, honey. I do not want to make trouble. I do not want to make your life miserable. But you don't set the rules. Mrs. Som has established the rules, and we're all going to follow them. And if we don't, there are consequences. And I don't want to go there. I really don't. But I got to see your face. Okay? So, Lainey, I don't know where you're slouching down and all that. I got to see your face. From now on, I'm just marking you absent. I'm not talking about it. I'm not mentioning it. I'm marking you absent. Are we clear on that, everybody? All right. I'll see you next time.
Yes, ma'am.